Okay, we're at the top of the hour and ready to start this month's webinar. So hello and welcome to the next in our series of critical infrastructure solutions from Rahi Systems. My name is Marcus Doran and I'm the General Manager for Rahi Systems here in Europe. And I'm delighted to be joined in this month's webinar with our partners from Western Digital and their Marketing Director from EMEA, Naresh Chushan. So the obvious topic of discussion for this month's session is enterprise storage. And we're probably safe to say that storage hasn't always been top of mind in the world of IT. But the success of your business, whether you're a company of 5 or a global 500 company, does lie within your storage strategy. I suppose if you look at it this way, nobody would want to build a new office or a factory with a weak foundation. So the foundation obviously has to be secure and rock solid and consist of the most reliable components. The same does go for your storage. Storage is the critical foundation of your cloud and data center environments, and I suppose in short, it's the foundation of your business. If we look at smartphones and the web today, we are all seeing the exponential increase in the vast amounts of data that is being produced, and the trend is only going to go up this year and beyond. I suppose in 19, how you use, maximize and optimize your oceans of data will continue to play a pivotal role in your business. So today we're joined with Naresh, as mentioned. He's the EMEA Marketing Director for Western Digital Data Center Systems Business Unit and is responsible for all of Western Digital's marketing efforts within the region. Naresh came to Western Digital through the acquisition of Tegile, where he was one of the leadership team members for the IntelliFlash product range. His remit covers Western Digital's full range of data center solutions, from IntelliFlash to ActiveScale, through to the new architectures such as OpenFlex and general platforms. So again, welcome, Naresh. We would encourage the attendees today to put their questions through the chat box, and what we'll do after Naresh's presentation is circle back and come back to those. So again, thank you to all for joining, and I will pass you over to Naresh.
Hello, good morning, and thank you for attending today's presentation. During the presentation, I'm going to be sharing our insights into some of the challenges and impacts of NVMe and NVMe over Fabrics is going to have on data centers of the future. My name is Naresh Chauhan, and I'm the EMEA Marketing Director for Western Digital's Data Center Systems Business Unit in Europe. In order to provide some context of what we see as the evolution of data, and therefore the evolution of data centers, let's take a look back over the past few decades. Previously, data that would have taken over 250,000 years to process in terms of compute power, network and storage performance can now be processed within one day, so that the performance of data centers has increased vastly. Secondly, the value of data is changing dramatically. Previously, it was felt that only 1% of data generated was deemed as monetarily useful, which led to large amounts of unused dark data being stored but underutilized. Today, we see organizations realizing monetary values of up to 10%, and currently there's deemed to be around $15 billion worth of value from dark data alone that has been generated within the healthcare industry. Now let's take a step back and look at a typical company. Every company has large amounts of data, the majority of which is generated in specific silos or applications, so ERP, CRM, data warehousing systems. Each application only knows the data that is generated within its siloed environment. For example, at Western Digital, our IT department is gathering massive amounts of data about our flash SSD drives in the manufacturing environment. We have a lot of information about specific drives, the flash management algorithms, the firmware versions, the manufacturing processing and errors. And having this data accessible to be correlated during the early stages of a new SSD design enables Western Digital to better predict what impact certain design changes will have on the future of design. Having data at the center enables different applications to use that data. For example, having Salesforce interconnected with Marketo and tools such as NetSuite allows marketing and sales teams to share data to create better campaigns, gain better insights into buyer behaviors, and identify and close business deals a lot faster. Exchanging and correlating data between applications enables companies to realize better end-to-end insights, and the value of data goes up several magnitudes. Lastly, when dealing with large amounts of data, there are some serious privacy concerns. The recent leaks on Facebook illustrate how people have used our private data to impact certain outcomes. We are going to be living in a data-centric world, a future defined by how our data is captured, how it's transformed, and how it is utilized. Data privacy is paramount for protecting us all in this new data-centric environment. Today, we live in a data-centric world. We are gathering data from many different sources, from social interactions that we have on our mobile devices, to how we interact with our cars, to wearable devices, gathering health information. If you can analyze this data, you can deliver some phenomenal insights and truly unlock the value of data. You're going to find all types of data where you must make decisions quickly. Data will come at you with massive velocity, massive variety, and massive scale. How will you unlock the value of this data, and how will you make the right set of decisions? Why is the data there in the first place? Data is being collected to make better insights and decisions. For example, in agriculture today, if you have a drone flying over vast fields, the image captured can help figure out where crops are growing well and where they are not. Farmers can make real-time adjustments by correlating these images with past data sets of historical crop rotations and environmental conditions. Where things are going, if farmers can embed small, cheap IoT sensors in the soil where water has flowed in the past, it makes it phenomenally easy to gather information and make better decisions connected to the output of their farms. Companies across many industries aggressively use data to transform their businesses. The point is, we're finding a variety of data sets, big and fast, but what does this all mean for business? Data interaction is changing. In the past, data used to be held captive by the application. Today, if you can put data at the center of what your business is trying to do, you can create, you can access, you can transform, you can make insightful decisions. For example, you went to Amazon website and bought something. Now, based on your pattern, based on which sets of pages you've navigated to, we can now form a mental picture of what your real interests are. What are you likely to going to buy? In a similar context, if I can put data at the center of that, and you have a variety of different applications access, now it becomes a very powerful situation. Data that is pooled and shared by multiple apps. Very simply, Amazon records your search history. If a search application only stored that data separately, intelligent buying algorithms and applications could not use your search criteria, page navigation, etc. How can another application form a rough mental picture of what your interests are? Amazon has a common or shared pool of data that allows different applications to really understand and to come up with these insights. Data interaction is changing and driving new demands on data infrastructure. Scale. As data integration is changing, you think about the scale we need to operate. For example, for every Amazon user, we are generating multi-terabytes of data based on navigation patterns, clicks, search histories, etc. If you multiply this by thousands and thousands and hundreds of thousands of users, coupled with lots of different applications wanting to get access to that data, this is a really large-scale problem. Secondarily, if any data infrastructure, if you're trying to consolidate, needs to be able to support the variety of applications, the variety of transformations, and the variety of users, so scalability is an important element. Let's look at agility. The infrastructure needs to be agile as well. Needs are constantly changing. At different times of the month and at different times of the year, we need certain bandwidth, throughput, and performance. When customers enter the shopping season, there is substantially more activity to handle. Will your data infrastructure provide the ability to essentially handle bursts? Can you reform the infrastructure on the fly to meet the changes in business needs? Now, efficiency. We all know that there is a massive amount of data, and how do we ensure that it's stored on the right infrastructure so that we are keeping the optimal efficiency associated with the data? In other words, how do I ensure the right sets of data are in the right place and at the right time? How do I ensure the right set of data is actually on the right infrastructure to optimize and minimize my costs? Looking at performance, we all know that faster data infrastructures enable companies to achieve faster data insights and maintain a stronger comparative advantage. We are in the midst of a data infrastructure revolution. If you think of the data infrastructure, it is evolving from dedicated platforms to fluid hyperconverged to one that is more composable and defined by software. If I have a data infrastructure that is fluid, it helps me break down data silos. Then I can achieve better efficiencies by avoiding silos of data and ensure that my infrastructure costs match my business needs. Mobility of data ensures putting the right data on the right tier of storage. Let's talk about the benefits of dedicated versus composable infrastructure. In a dedicated infrastructure, you have a brick with compute, network, flash, and HDD. In the context of hyperconverged itself, that is how people are deploying. We have all known that we are all going from dedicated physical infrastructure to more virtualized infrastructure, which is still operated at a little bit in silos. Compute versus network versus storage, etc. And then came hyperconverged, which brought all of these together to simplify the management, deployment, and provide levels of simplicity that was not seen before. But hyperconverged and even dedicated systems brought a different set of problems. Even in the context of hyperconverged environments, you grow by adding a certain type of brick with compute, network, and storage. If you have a wrong type of brick and you do not have the flexibility to move your applications and data to the right class of brick, i.e. compute and storage. If you disaggregated everything and had the ability through software to just grab the amount of compute you need, the amount of network you need, the type of storage you need, whether it's flash or HDD for the use case you need, you can now create logical pools of resources that deliver compute, network connectivity, and the amount of storage you can deliver on those four elements: scalability, efficiency, agility, and performance. The on-demand composability provides the agility we need, and emerging standards like NVMe and NVMe over fabrics maximize performance by reducing I/O bottlenecks within storage servers across networks. So what are the benefits of composability? In the ideal scenario, you're going to get great economics, agility, efficiency, and simplicity at scale. More importantly, a composable infrastructure is applicable to a wide variety of different environments. Some of that are virtualized in nature today. In the future, it could be containers. It could be bare metal apps similar to earlier dedicated configurations, highly optimized for specific compute, network, and flash. If we are able to deliver this through composable infrastructure, the benefits are tremendous. Up to 40% lower TCO than traditional dedicated and HCI infrastructures, approximately 50% savings in the initial CapEx investments, bringing on what you need. I track inactive dark data center resources and configure what you need to meet the demand and reduce the CapEx. So we'd like to talk about our vision of an on-demand data center infrastructure of the future. Firstly, it needs to be extremely open. You should be able to bring in any of the sets of resources, i.e. compute, GPU, networks, flash, and different grades of persistent storage. What we need is the ability for these vendors' solutions to come together under one management infrastructure that allows composing infrastructure components on the fly. They need to talk to the same API. Let's talk about scalability. We need to be able to independently scale whatever our needs are, whether it's capacity, network bandwidth, performance, and what we have to be able to do is be able to do this within a rack or across multiple racks. It also needs to be totally disaggregating. Having the ability separate and assembly components completely on the fly will provide tremendous flexibility and scalability. Scaling that is completely driven by the needs of the application, so that you're in an environment, you're getting the optimal structure for delivering the application based on the application service level. Extensibility. We know media is changing, the compute is changing, entities themselves are evolving. You need an extensible infrastructure to be successfully able to manage the components and different grades of storage media. So I'd like to share with you Western Digital's vision. Having an open, extensible infrastructure, we can deliver on the promise of delivering purpose-built, flexible infrastructures which meet the service levels required by the application. You will always have the need to deliver multiple storage options. For example, Rack A has a high-performance storage immediate option, needing very fast flash configurations and multiple persistent memory types shared over a fabric. And in Rack B, a very dense, low-cost media option, leveraging very high-capacity drives. Not everything will need to be stored on flash. We all come up from a world where we believed DAS was great. However, DAS has the problem of siloed data, where data is captive inside the server enclosure. We see the need to share persistent memory on a shared fabric like a SAN or a NAS to eliminate silos and enable flexibility to compose the optimal scalable infrastructure needed with different types of persistent memory. That brings us to how we achieve a composable infrastructure. To achieve disaggregation, we need connective tissue or extensible interconnect to stitch the compute, memory, network and storage elements together. If everything needs to be composable, there needs to be a fabric to allow components to talk with one another and move data between the different compute resources. What is that fabric? Today, Non-Volatile Memory Express, or NVMe, delivers on the promise of creating a fabric that essentially brings together all these elements. We need a very high-speed interconnect. NVMe defines non-volatile memory protocol and a command set to allow CPUs and GPUs to access persistent memory as memory over a data fabric. NVMe provides the necessary protocols to abstract the underlying persistent memory devices. There is also a need for high-speed interconnect required between CPUs, GPUs, FPGAs, and memories, so you're now not moving data around, but have a shared memory area between components. NVMe and NVMe over fabrics are the standards, protocols, and semantics necessary to stitch components together, some over data fabric and some over memory fabric. Western Digital recently announced its proposal for the Open Software Composable Infrastructure, i.e. SCI, and the Extended Fabric, a new high-speed memory fabric. For more information, please download the Western Digital Technology Brief, and the link will follow shortly. So why NVMe? Today, interest in NVMe is growing at an explosive rate due to a couple of factors. Firstly, application demand. To provide real-time interactions and experiences to end users, applications need faster storage that can read and write a tsunami of data very quickly. Legacy storage technology simply cannot keep up with the performance demands imposed by new application environments. Secondly, continued innovation in solid-state storage. Over the past decade, flash use has expanded as form factors, newer types of solid-state storage such as storage class memory, and now NVMe and NVMe over fabric standards. NVMe addresses many needs. Firstly, the protocol is designed specifically for flash memory to accept data workloads. It's also designed to provide direct memory access to persistent storage, bringing data closer to the CPU. There are increased I/O queues, multiply data throughputs and complete I/O tasks faster. Faster access to flash accelerates latency. Faster access to flash accelerates latency-sensitive workloads, offering better TCO and ROI. Higher PCIe bandwidths than serial attached SCSI or SAS enables scaling to high-performance storage platforms. An optimized over NVMe fabrics standards extends NVMe benefits across fiber channel, Ethernet, and RDMA networks. One of the most important elements to achieve composability is that it has to be completely orchestrated and managed through software. In the future, as these different elements and devices evolve, they need to speak common languages. For example, on the storage side, they need a certain set of APIs that come natively in the system to control and manage the media, automate discovery of different resources, figure out the peer-to-peer connections, and be able to orchestrate resources through standard APIs. The key message: APIs are absolutely critical. Standardization is important, and we at Western Digital are driving those standards. We expect these elements of the data center of the future will have well-defined APIs to allow for orchestration. For more information, see Western Digital's Redfish and Swordfish orchestration standards. Western Digital also recently announced the OpenFlex architecture, defining a high-level API abstraction that allows for composability on the fly. In addition to manufacturing our own flash memory devices and NVMe controllers, we offer an extensive portfolio of NVMe data center storage components, systems, and infrastructure solutions for big data and fast data applications. Let's look at the UltraStar DCSN200 NVMe SSDs, which deliver a new level of performance and capacity for enterprise, cloud, and hyperscale environments. These locally attached NVMe drives accelerate access to critical data for data-intensive server workloads and applications. The UltraStar NVMe extension drives scale in memory computing infrastructure and servers at a better total cost of ownership. UltraStar NVMe drives increase application memory by creating virtualized memory pools. The UltraStar NVMe platforms are a key element of next-generation disaggregated storage and software-defined systems, delivering high density and the flexibility to balance performance with cost. The OpenFlex platform provides the building blocks for organizations to build composable infrastructures, enabling the transformation of data centers into highly scalable and flexible software-defined storage environments. The IntelliFlash N-series platform of all flash-based and flash and hybrid-based arrays delivers extreme performance with exceptional economics for a wide range of workloads in the data center. To learn more about the N-series all-flash arrays and each of these NVMe products, please visit our westerndigital.com website. Western Digital has several families of NVMe and SAS flash-based SSDs and disk-based SSDs, HDDs for composable infrastructures. We expect to see more and different types of devices from the industry this year. Fabric devices allow multiple paths and the network is matched to the needs of the specific storage media. Powerful orchestration tools allow faster composition of virtual systems that will continue to drive time to market and innovation. If you're looking to architect a data storage infrastructure that is elastic, efficient, and based on open standards, then you should look at our OpenFlex composable infrastructure solutions. Based on NVMe over Fabrics, the OpenFlex architecture enables the disaggregation of compute, network, flash, and hard disk storage and other resources into highly scalable resource pools on a single fabric for on-the-fly provisioning when and where it's needed. On one hand, we have the OpenFlex F3000 high-performance, low-latency devices for fast data, for artificial intelligence and real-time analytics applications. Similarly, we have the D3000, where the D stands for high-density devices for big data applications, batch analytics, machine learning, and predictive modeling. Our OpenFlex Fabric platforms are based on open standards APIs, enabled enterprises to accelerate applications and utilize resources more efficiently, saving up to 40% TCO when compared to that of traditional HCI infrastructures. At the heart of any effective system is a well-chosen Tier 1 storage platform. Introducing Western Digital's N-series, 100% enterprise-class NVMe all-flash array from Western Digital. The N-series extends the digital IntelliFlash product line, which already offers super-fast high-density AFAs. With NVMe built in, the N-series offers even faster performance, value, and scale. We can accelerate applications and cut data analysis times in half. Total cost of operations and built-in data reduction features, shrink storage footprints, lowering power consumption and reducing the overall TCO of storage. Modern software architectures provide both block and file protocol access, consolidating workloads for specific needs into one array. The N series comes in two versions, the N5200 series for read-intensive workloads and the N5800 for mixed read-write intensive workloads, providing 8 NVMe flash capacity options ranging from 20 terabytes to 100 terabytes raw capacity in a 2U form factor. The performance and density improvements from NVMe increase value and unlock new use cases for N-series AFAs, including database acceleration, analytics, machine learning, and modeling, as well as Tier 1 application consolidation. The data center infrastructure of the future is complex and needs to be open, scalable, disaggregated, and extensible. Western Digital is leading the way with the development, interoperability, and deployment of products based on open standards for non-volatile memory, high-speed composable fabrics, and advanced storage management APIs. These standards simplify managing and composing the storage elements that make up the data center of the future. Thank you very much for your time, and there are some questions and answer sessions a bit later on, so please feel free if you have any additional questions to approach us. Thank you very much.
Okay, so thanks for that, Naresh. We have a number of questions in the chat box, and again, thanks to those who have submitted the questions throughout the presentation. We're going to get through those as quickly as we can. So the first question in, Naresh, is how quickly will data centers migrate to NVMe of Fabric Interconnect, and are there any intermediate steps that will allow the data center throughput?
It is clear that data center migration to a full NVMe over Fabric Connect is going to take a significant amount of time, perhaps a couple of years at least. But there are some intermediate steps that you can take. For example, the Western Digital N series array is already NVMe based, but it uses PCIe Connect to connect to the backplane and then onwards onto Fiber Channel or iSCSI based, SANs and NASs. So people can take advantage of NVMe today.
Question number 2, how does NVMe differ from existing interface standards such as SAS and SATA?
The NVMe protocol capitalizes on multiple parallel low latency data paths to the underlying media, similar to that of high performance processor architectures. This is significantly higher performance and lower latencies in comparison to legacy sort of SAS and SATA protocols, which are predominantly serial. This not only accelerates the existing applications that require high performance, but enables new applications and capabilities for real-time workload processing in the data center, both at the core and at the edge. Conventional protocols, consumed lots of CPU cycles, which is another considerations. So lots of CPU cycles were being used to make data available to applications. These wasted computer cycles, cost the businesses real money, and IT infrastructure grew in size. However, budgets were not growing at the same pace, and therefore they put a tremendous pressure on data center infrastructure overall. Because NVMe can handle rigorous application workloads with a smaller infrastructure footprint, organizations can reduce the overall cost of ownership and accelerate top-line business growth.
Okay, a couple of more questions. And question number 3 is, what is the performance advantage of using NVMe now?
The performance of NVMe can generally vary depending on the actual workload and the read-write balance between the compute architecture and the actual memory infrastructure. In most cases, what we've seen is at least twice the performance, but in a lot of cases, we can actually see up to a magnitude improvement in performance overall by using NVMe.
Okay, and time for one last question. Question number 4. Why should you adopt NVMe now and not wait for new architectures to be developed?
Aside from the technical reasons as to why you should adopt NVMe, i.e. aging protocols, which were singular path rather than parallel path command structures and the extensive command structures that NVMe brings, there are some sort of key commercial reasons as well why you should look towards moving towards NVMe and or Flash. Flash in and of itself is high performance, very high performance, and probably meets the requirements of most people's workloads as they are today, but those needs are sort of growing all the time and improving, increasing in magnitude as well. But moving towards Flash is generally going to lower overall TCO, not only in terms of the footprint because of the high densities now achieved during using Flash technologies, but also the overall OPEX costs of running data centers in terms of reduced heating and reduced air conditioning, all those unreduced power as well, and all those other facets that go alongside the adoption of Flash as well. So NVMe is just a pathway. It fits in with the existing Flash array structures and existing SAN and NAS structures as well. So and it's not at considerably more cost than what all Flash arrays are right now. So definitely worth a consideration for your data center.
Excellent. Thanks for answering all of those questions, Naresh, and also thank you to those again who have attended today and submitted the questions through the chat box. For those that we didn't get to, we'll come back individually and answer those. So I'd like to take this opportunity to thank you again for attending. For more information on our storage solutions, please come to our website at rahisystems.com, and we look forward to seeing you all on our next webinar next month. So again, thank you for joining and have a great day.